Hello and welcome to The Hindu. I am Ramya Kannan, the health editor. Today we are looking at a fascinating concept turned prototype. In Graz, an Austrian city, sometimes things get so cold in winter you can hardly feel your fingertips. It is in this city, at the university, TU Graz, a team of scientists have perfected a prototype for guess what? Artificial skin. Yes, you heard that right. You've heard of wearables. Why? You might even be wearing some of them. But this prototype gets really close to the human skin. SmartCore artificial skin, crafted by Dr. Maria Coclite and her team at TU Graz, is a groundbreaking leap in material science and also medicine. Made of a smart polymer which changes thickness depending on humidity and temperature, this skin is reportedly far more sensitive than human skin. It works by simultaneously sensing pressure, moisture, and temperature and converting them into electronic signals. Typically, human skin has a resolution of 1 millimeter square. So, this means that if you have an object that is 1 millimeter square or bigger, you can feel it with your fingertips. With the device that they have produced, they were even able to measure an electrical current from a pixel that was merely 0.25 millimeter square, smaller than 1 millimeter square. So this means that you can get information also on smaller areas than the human skin. Today, we speak to Dr. Maria Coclite to understand more about this device, its practical implications in human life, and how long it will take for the product to reach the shelves, as it were.
So artificial skins are a series of materials that try to emulate the functionality of our skin. Of course, our human skin is very complex. It has a lot of functions, not only sensing, but also, thermal regulation, protection, really a lot of functions. And artificial skins try to emulate at least some of the functions.
Right.
In our particular case, we focused on the sensing properties. We tried to include in our device some sensors for humidity, temperature, and pressure, so that, like in human skin, you would feel if you are touching something colder or warmer. Similarly, also this artificial skin differentiates between colder, warmer objects, objects with spikes, objects without spikes, and so on. The project that really signed at the beginning of us working on artificial skin was funded in 2016. So one could say that from that time we are working on this project. But already before that, we were working on the materials that then have been used in this type of device. For example, one of the material is a smart polymer, which changes its thickness depending on humidity and temperature. And this type of smart polymer, we were already developing it from before the project was funded. Then, of course, because it's difficult to do things without funding. So the real work started once the funding agency approved the project proposal, and yeah, that's when we really started to work on artificial skins.
So, what are the actual practical uses of the artificial skin? Is it therapeutic, or does it have like an engineering purpose? What are you planning to?
We are still looking a bit more into this application, so there is not really one specific field at the moment that has been already defined. But for example, it could be used on prosthetics. So the artificial skin could cover prosthetics, and then help the patient, the amputee patient, regain the sensation. Um, so I wouldn't say that it would have a therapeutic effect, but it could have some healthcare, could be used for some medical device to, for example, give back the sensation to people that have lost. Or it could be also used in robotics, so not necessarily for biomedical application, but also for some robotics.
So, were there any biomimetic approaches, inspiration from nature, non-human, but other in terms of sensitivities and recording, the ability to record differences, changes in pressure, apart from the human skin itself?
Well, it's an essential characteristic of living beings, So, but it always comes a bit from the skin. Um, Other biomimetic examples that are, for example, that show this change in thickness depending on temperature and humidity are also, for example, if you imagine pine cones or the leaves of plants, they also show this kind of um, change in shape and thickness depending on humidity and temperature. So the smart polymer uh, in some ways emulates what other phenomena that are in nature.
Right, right. That's very interesting. So when we're talking about using polymers, something that's really sort of bothering the world today is whether our research is sustainable, um, whether we have addressed environmental considerations in the development of materials for artificial skin, their use, of course, but also their disposal, and how do we make uh, everything more eco-friendly and sustainable? Have you thought about this? I'm sure you have, but can you talk about it?
Yeah. So first of all these sensors that we use are all made of thin films. So they are all made of films that are much smaller than 1 millimeter. And so this means that the material used is really, the quantity of material used is really small, and therefore there is not, let's say, too much of footprint that is left from these materials. What is mostly, let's say, the thickest part of this whole device is actually the substrate. So where the material on which we place the sensors. And so far we have used the plastic foils as substrate, but one could also deposit these sensors also on paper foils, and paper is much more biodegradable. So the technology and the sensors are not dependent on the type of substrate, and this means that one could uh, make them also much more eco-friendly than
Right,
our
right.
first prototype.
So when we're talking about prototypes, how long do you think that this goes from lab to bedside? In a manner of speaking, of course, it can be used, as you mentioned, across sectors. But how long do you think this will go from a successful prototype to actual use on the field?
We are working exactly on this part, on trying to make this step. Um, I hope another 5 years max.
Oh wow, that's lovely. I mean, it's quite ambitious, but then considering that you've already rolled this product out, I think one can trust that you will go the whole mile in 5 years. Sometimes, discoveries in science are serendipitous. No doubt they are important too, considered from the point of utility for humans. But here is a project that was conceived and implemented with the specific target of achieving a human-like skin. Never mind that they did one better. As we heard from Dr. Coclite, the next stage for this artificial skin is to get completely wireless and the signals to be integrated with neural networks in our brains. Imagine that. One day we might just have a thin layer of artificial skin that someone who has lost a limb in an accident might be able to patch on to a prosthesis and then begin to feel. And for people debilitated by severe burns, here is a skin patch that can feel and seamlessly integrate itself physically. Imagine the possibilities of that. They are in the future, we know, but these are the possibilities of science that make future all that better. For more such videos like this, subscribe to The Hindu.